Our first speaker of the afternoon here is Ben Best. Some of you guys are familiar with Ben. He's been in the life extension community for quite a while. In fact, he used to live in Vancouver here back in the day, but now you're based out of, is it Florida? Based out of Florida? Yeah. So he's going all the way up here today. I believe his topic today for us has to do with supplements. So just go ahead and hand it over to Ben here. Thank you.
Yeah, okay. So I got my pharmacy degree here at the University of British Columbia, and another degree in physics and computer science from SFU. So I'm not new to this area at all. So I want to begin with a story of two physicians in an airplane, actually, flying a plane. And the plane developed engine trouble and started going down. And so one of the physicians said, we've got to jump. And he started putting on his parachute. And the other physician started walking towards the hatch. And the physician putting on his parachute said, aren't you going to put on a parachute? And the other physician said, parachutes have not been shown to save lives in a clinical trial. So, the problem with clinical trials is that there isn't much financial incentive for non-pathogenic substances. The gold standard is randomized double-blind placebo, but double-blind studies are often impossible for exercise, massage, diet, parachutes, so forth. And they can often be based on poor understanding. Can lead to wrong conclusions and have incorrect assumptions. My favorite example is the Women's Health Initiative for hormone replacement after menopause. It's just important to use a good judgment on all possible sources of evidence. Let's see, let's skip all this about that. And then there's epidemiological studies, which are based on the characteristics of people. And the data is often misinterpreted, important variables are ignored. I'll give you a semi-hypothetical example, a study that will show that people who take nutritional supplements are less healthy than those who do not. So are the supplements the cause of poor health, or do people with poor health take supplements hoping to cure themselves? There are many bad epidemiological studies and clinical studies, but there are many good studies of all kinds of. And as I say again, you need to use a lot of judgment. So there's already been a lot said today about lifespan versus health span, and too many giant gerontologists, unfortunately, equate lifespan with maximum lifespan, and as actually increasing health can increase lifespan without increasing maximum lifespan. It's called average lifespan, applied to many people. But it's closely related, but not totally equivalent to health span. The more healthy you are, the more likely you are to live, and the more likely you are to benefit from life extending technologies. So avoid smoking, exercise, eat a good diet, take supplements. It could add decades to your life if you're not lucky enough to have these genes that the super centenarians seem to have. And so Aubrey de Grey's talks about getting to escape velocity, where you can essentially avoid dying altogether due to subsequent living long enough to benefit from subsequent technologies. So you don't need to increase maximum lifespan to achieve this escape velocity, I think. So this is we've seen a lot about squaring curves and so forth today also, and so we want to, before sense or other technologies extend the maximum lifespan, we want to get the most benefit we can by squaring the curve, living as long as we possibly can in optimal health, up to what's evidently a genetically based maximum lifespan for our species. So here's an epidemiological study of over 5,000 male veterans found that every incremental increase in exercise capacity lowered mortality 12%. So how do you interpret this? People with higher exercise capacity, are they healthier? Or people healthier are able to exercise more? Or maybe people who are unhealthy cannot exercise. So it isn't proof that exercise improves health or health span. There are intervention trials, though. A randomized clinical trial showed that exercise is more effective than metformin for reducing diabetes. And 12 weeks of exercise raises HDL cholesterol, lowers blood pressure. And exercise increases wound healing. And exercise has been shown to increase blood vessel growth and volume in the cerebral cortex of rats, which increasing brain health is obviously a part of health, what we would call health span, and probably is related to lifespan. But as far as exercise, there's a cautionary note. About 10% of heart attacks are associated with vigorous exercise by obese smokers unaccustomed to exercise. Supplements are being put in. Many health authorities commonly claim dietary supplements are of no benefit and that food supplies all nutritional needs. But actually, iodine has been added to salt since the 1920s because iodine was discovered to prevent goiter, and goiter was widespread at that time. But on the other hand, salt restriction is now recommended for people worried about their high blood pressure. Vitamin D has been added to milk since 1932 because urbanization led to a reduced sunlight exposure. Rickets had become more prevalent. But 90% of Asians and 70% of blacks are lactose intolerant. And vitamin D is not water soluble, so if you're going to drink skim milk, you're getting less vitamin D. Folic acid has been added to grain foods since 1998. Folic acid reduces neural tube defects in fetal development for pregnant women, but carbohydrates promote obesity. As of 2012, governments in over 67 countries require food fortification. So does that mean that because of this supplementation of food that it's supplying all of our requirements? There's also voluntary commercial supplementation of food. For example, Special K has lots of vitamins and minerals. They added so many vitamins and minerals that the government of Denmark outlawed addition of vitamins and minerals to Special K in their country. They just didn't like that supplementation, I guess. Fish oil, the U.S. National Institute of Health recommends fish oil, which is high in omega-3 fatty acids, to prevent or reduce high plasma triglycerides, high blood pressure, cardiovascular disease. And the American Heart Association recommends 1 gram of fish oil daily in the form of fish for coronary artery disease. But pregnant and nursing women are advised to avoid mackerel, shark, and swordfish due to the high levels of mercury. These are fish that are high in the food chain and therefore tend to concentrate the mercury more. But fish oil supplements have less mercury than fish. And because the mercury binds to flesh, it doesn't bind to fat, it doesn't bind to the oil. And the supplements are made from smaller fish, and the oil is distilled. Omega-3 fatty acids counteract the pro-inflammatory, pro-allergenic effect of the omega-6 fatty acids, which seem to dominate in our food supply, mostly due to vegetable oils. Supposedly humans were evolved for a 1-to-1 ratio between the omega-6 and omega-3 fatty acids, but in Western diets we're getting something more like 15-to-1, which is leading to these pro-inflammatory, pro-allergenic effects. 40% of the polyunsaturated fatty acids in the brain is the omega fatty acid DHA. And our ability to synthesize DHA declines as we get older. Omega-3 fatty acid supplements given to persons with mild cognitive impairment has been shown to prevent cognitive decline. And I might mention my company, Life Extension Foundation, sells vegetarian source DHEA, which comes from algae and culture. It doesn't have mercury, dioxin, PCBs that can be found in fish oil. And this is what I take. Dietary, there's only 68% of Americans are American adults. Now, I apologize for all the American data, but that's where a lot of the data is, not Canadian data. 80% of adolescents do not eat 5 portions of fruits and vegetables daily. The 2010 Dietary Guidelines for Americans recommends 9 servings daily, 4 servings of fruit, 5 servings of vegetables, based on the 2,000 calorie diet. A 2010 survey found that the average American eats 3.6 servings of fruits and vegetables daily, which is well below these recommendations. The World Health Organization estimates that 31% of cardiovascular disease deaths are due to inadequate consumption of fruits and vegetables. Diet often does not supply adequate vitamins and minerals. Bruce Ames, he's famous for the Ames test for detecting mutagens in bacteria. Now, he recommends a daily multivitamin and mineral tablet as an insurance policy against insufficient dietary micronutrients for all these people who are eating less than all these servings of vegetables fruits and vegetables they're supposed to be having a day. So he actually uses a more conservative estimate for there's a recommended daily allowance, and he uses estimated average allowance, which is more conservative than it's 2 standard deviations. The RDA is 2 standard deviations above the EER, and whereas the RDA is believed to meet the needs of 27.5% of healthy. EAR would only meet the needs of 50% of healthy adults. Wait a minute, I maybe got that backwards. Anyway, using his EAR guideline, 56% of people in the United States are getting less than the EAR in their diet, and 12% are getting less than the EAR of zinc, 93% less than the EAR of vitamin E, and 91% less than vitamin C. And for menstruating women, they're not getting enough iron, 16%. So this is all based on, but anyway, this is based on a paper by Ames. Magnesium deficiency is associated with sudden cardiac death. This deficiency can be treated with supplements. Dr. Ames doesn't provide an ear for vitamin D, but he notes that deficiency is associated with cancer and nursing home admissions. An estimated 30 to 90% of the elderly are vitamin D deficient. Now, 30 to 90 is a very wide range because, well, the definitions of vitamin D deficiency vary quite a bit. It can mean more than a prevention of rickets, because vitamin D has many functions other than for calcium absorption and bone density. The elderly have reduced skin vitamin D synthesis in the sun. Their skin doesn't synthesize vitamin D as well, and they spend more time indoors anyway. But I'm not saying that some nutrients are essential, but they're toxic in high doses. Vitamin D can be toxic in high doses, but probably at higher doses than the current official upper limits. And vitamin D is also very toxic. Actually, the polar bear liver has been said to cause fatalities even because it's so high in vitamin A. And selenium is an essential mineral, but it's toxic in high doses, or even reasonably 400 micrograms actually is supposed to be the upper limit. The cattle in the prairies eating local weed or eating selenium tends to be high in the soil in the prairies. So cattle that would eat the grass there sometimes would get selenium toxic poisoning. And more is not better. calcium supplementation can reduce fractures somewhat, but it can also lead to calcified blood vessel plaque. Vitamin K could help ensure that calcium goes into bone rather than blood vessels. But calcium in food does not have the bolus effect of supplements. The food results in slower absorption, is therefore less likely to calcify blood vessels. This is definitely a very strong argument for getting your calcium from food rather than supplements, because you're not getting that sudden rush of calcium that can end up in your blood vessels. So I'm not just a huckster. Anyway, and also this other study recommends calcium supplementation only used for institutionalized elderly women who are at high risk of fracture. So I want to say something about oxidants and antioxidants. To explain what's a free radical? It's a molecule with an unpaired electron. So electrons normally come in pairs. They'll be in the same orbital but opposite spin. And a free radical has an electron that's missing a partner. A free radical is a hot potato that can damage macromolecules like proteins or DNA. And they'll turn another molecule into a hot potato while ceasing to be a free radical. In other words, they cease to be unpaired. The hot potato isn't an extra electron. It's the absence of an electron partner. So you have to sort of think backwards about this a little bit. If the receiving particle is large, like lycopene, and the donating molecule is small, like the hydroxyl radical, the new free radical will likely be less reactive. Lipid peroxidation is a chain reaction that's both damaging and passing of electrons. So even though the lipids will be neutralizing a free radical, they're becoming free radicals, but cause a chain reaction of free radical oxidation. Now, the small hydroxyl radical causes half of the body free radical damage. It's an extremely damaging free radical. I noticed the dot here. That's just to indicate the unpaired electron. So when we're talking about the hydroxyl ion, which has this minus sign because it's got the extra electron, we could write it like this, showing the paired electrons on the oxygen. So I'm just showing you, this is just a special kind of chemical notation that's sometimes used when describing free radicals. So many phytochemicals from plants are large antioxidant molecules like lycopene, beta-carotene, isoflavones, anthocyanins. And the reactivity of a free radical can be quantified by one electron reduction potential. So I'm showing it, and this shows here that the hydroxyl radical is right at the top of the list. These are radicals from lipid peroxidation. And these three are actually antioxidants, but since they perform their antioxidant function by donating electron to say a hydroxyl radical, they've ended up becoming free radicals themselves. So there's your glutathione radical and your tocopherol radical and your ascorbate radical. So Denman Harmon, he developed the free radical theory of aging, and he found that antioxidants could extend the mean lifespan of short-lived mice, but not the maximum lifespan. But an experiment in 2005, published in 2005, showed that overexpression of the antioxidant enzyme catalase in the mitochondria of mice would extend both their maximum lifespan and their mean lifespan by 20%. So that's a good proof in principle that reducing free radicals inside the mitochondria, which is where most free radicals are generated, can actually reduce aging. So why don't antioxidants normally extend maximum lifespan? Well, they can't get into mitochondria is one problem. And then, as I mentioned, as I showed, they turn into pro-oxidants after neutralizing a free radical. And also, there's actually homeostatic mechanisms in our cells. If we put antioxidants in, it may signal the cell to produce fewer of the natural antioxidant enzymes. And finally, mitochondria generating a lot of free radicals those free radicals act as a signal to stimulate the destruction of those mitochondria. But if you're not getting this signal of the free radicals, then those mitochondria are not destroyed. So, but this refers to free radicals outside the mitochondria, not inside the mitochondria. So let me say something about vitamin E. Vitamin E actually refers to a whole bunch, several tocopherols and tocotrienols. There's alpha, beta, gamma, and delta forms. The alpha tocopherol is the most widely used tocopherol in supplements, and the gamma is the most common dietary vitamin E. It's in all these foods. Nitrogen dioxide and other reactive nitrogen species react with tocopherols. The molecular formula of nitrogen dioxide is this. Notice I've got the free radical dot over here, and indicating the unpaired electron. And it's a common reddish brown toxic air pollutant, probably the most common reddish brown toxic air pollutant. Now, if you add vitamin E to nitrogen dioxide, you get a mutagen. But the gamma E detoxifies the nitrogen dioxide. Also, gamma tocopherol is anti-inflammatory, but alpha tocopherol isn't. But when you supplement with alpha tocopherol, it drives down your blood levels of gamma tocopherol. So you're actually doing yourself quite a bit of harm there. And vitamin D, unfortunately, most experiments with vitamin E, so-called vitamin E, is done with alpha tocopherol, resulting in reduced anti-inflammatory action and increased damage by the reactive nitrogen species, resulting from suppressing the gamma tocopherol. So it's no wonder food is regarded as better than supplements if scientists are going to use alpha tocopherol for supplement testing rather than gamma. The gamma tocopherol is found in food. As I say, the experimenters almost invariably use alpha. Here's a paper. I was just looking at this paper talking about the study of vitamin E. And usually you can at least look in the methods section. At least they will disclose whether they're using alpha tocopherol. But in this case, all it says in the methods section is vitamin E. Here's a study. This was a meta-analysis of 19 clinical trials concluding that high dosage of vitamin E supplements increase all-cause mortality. But if you look at the discussion section, it only refers to alpha tocopherol. So it's no wonder it's increasing all-cause mortality. If it's reducing the anti-inflammatory effects of gamma tocopherol and increasing the vulnerability to these nitrogen species. Anyway, the Life Extension Foundation, another plug here, we sell vitamin E supplements that are high in gamma tocopherol, and that's what I take. So here's some other antioxidants. Vitamin C, as you may know from the diet, acetylcysteine, which is actually synthetic. But adding the acetyl group makes the cysteine more soluble, less reactive. It speeds absorption, and it increases the synthesis of our own body natural antioxidant, glutathione. Glutathione is the most prevalent natural antioxidant that's in the water-soluble portions of our cells. And lipoic acid, it's comes from the diet. It's found in spinach. Coenzyme Q, synthesized in the body, natural component of mitochondria. Melatonin synthesized in the body, hormone produced. It's a hormone produced in the absence of light, induces sleep, and it declines very significantly after the age of puberty, or the synthesis declines. So some of the properties, glutathione, vitamin C are only water-soluble, vitamin E and coenzyme Q are only lipid-soluble, but lipoic acid and melatonin are both soluble in lipid and water. And so the lipoic acid and melatonin more readily enter the mitochondria. And melatonin can cross the blood-brain barrier. And melatonin is twice as effective as vitamin E in preventing cell membrane lipid peroxidation. Melatonin is 5 times more effective than glutathione in neutralizing these hydroxy radicals. So, and actually some antioxidants don't even become oxidants. I mentioned that vitamin C and vitamin E become oxidants, and glutathione. Glutathione, it does become a free radical, but the free radicals combine. These two of the free radical forms of the glutathione will combine. And they've both got unpaired electrons, but the electrons pair when they combine into a single molecule. And then this is it becomes is regenerated into reduced glutathione with this enzyme. And lipoic acid doesn't become a free radical because it donates 2 hydrogen atoms. Hydrogen atoms are, from a molecular point of view, hydrogen atoms are about the same as electrons, since the nucleus has such a weak attraction for the electron in hydrogen. And melatonin actually donates 2 electrons. So just to show you lipoic acid, actually we're talking about dihydrolipoic acid. There's your 2 hydrogens, and they both get donated. Bruce Ames has used lipoic acid in his research, and he's also used acetyl-L-carnitine to get the lipoic acid into mitochondria. I said lipoic acid gets into mitochondria, but it can use a little bit of help, and the acetyl-L-carnitine does that. So he's shown that combining lipoic acid with acetyl-L-carnitine, it'll restore memory function in old rats. And then a later experiment, he showed that it did the same thing for old beagle dogs, for people who are concerned that rats aren't comparable to humans. But then he got down to the molecular level and showed that the molecular function in the brain mitochondria of old rats was restored by using lipoic acid and acetyl-L-carnitine. So the Life Extension Foundation, to say a bit about my organization, we fund life extension research. And we're a 501, the Life Extension Foundation is a 501c3 charitable organization. The Life Extension Foundation, LEF sells supplements, but the profits are used charitably. The specific charitable being life extension research. It's contributed to Aubrey de Grey's sense research projects. It's contributed to the Lifespan Society. It's contributed to many other projects. I'm the Director of Research Oversight for the Life Extension Foundation. I attend many conferences on aging and make recommendations to fund promising researchers. I've attended several Ellison Foundation meetings. There are meetings of the Ellison Foundation was funding scholars, senior scholars and new scholars to do research into aging, and I've gone to these conferences and found 3 of the researchers that once the Ellison money ends, these researchers are suddenly have a lack of funds. So I've found 3 of them that I recommended the LEF fund. So one of them was Victoria Balancio, Tulane University School of Medicine. I know when I met her, she was worried that she might have to close her lab when the Ellison funding ended, but LEF came to the rescue, and partially with our funding, she demonstrated that retrotransposons, which are the jumping genes that were discovered to, anyway, jumping genes, retrotransposons are genes that I don't know, jump, they can multiply and jump in our chromosomes, and they increase with age, and they also increase the incidence of cancer. And she showed that melatonin will reduce that activity. And anyway, this was the paper she published on that subject only a few months ago. And but that doesn't mean it's very rare. I mean, this is the only example I can think of offhand where we funded a project that relates to a project that we sell. It was actually a coincidence, I'd have to say, more than anything. I was just impressed with Dr. Balancio and her ability to do good research on a cellular level. I'll give you another example, and this is the example actually I'm most proud of, and that's Andrei Seliwanov and his wife Vera Gorbanova, who have the second largest naked mole rat colony in the world. There's never been a documented case of a naked mole rat getting cancer. And naked mole rats live at least 10 times longer than similarly sized rodents. Dr. Seliwanov was denied funding from the government, U.S. government, NIH agency, because the naked mole rat had been sequenced. So he was in danger of losing his naked mole rat colony. And his wife told me about this, his wife, Dr. Gorbanova, told me about this at a conference. And so I was able to get funding for them. And partly because of the funding that we provided, they were able to do more naked mole rat research. And they had a publication only a few months after their funding, in which they showed the very high fidelity of protein synthesis by the ribosomes of the naked mole rat. Anyway, because of this, and also this, they showed why they don't get cancer because of the contact inhibition from hyaluronic acid. Anyway, because of these discoveries, the journal Science named the naked mole rat the 2013 Vertebrate of the Year, and the naked mole rat research was a Nature cover story in July 2013, and Nature Reviews cover story in August 2014, just a few months ago. So those are the two covers. Nature Reviews Genetics is the foremost journal with the highest impact factor on the subject of heredity and genetics. So for summary and review, just to remind you, the 2010 Dietary Guidelines for Americans recommends 9 servings a day, and the average Canadian probably isn't much different than the average American in not meeting that amount of servings per day. And there's also this death due to inadequate magnesium. And supplements are an insurance policy against inadequate nutrition from the diet. And the more healthy you are, the longer you're likely to live, and the more likely you are to benefit from aging breakthroughs. And so avoid smoking, exercise, eat a good diet, and take the right supplements.
Thank you, Ben. So we have time for just a couple of questions here. We'll just bring the mic out if anybody has any questions, and then we'll go ahead and get things set up for the next speaker here. Yes.
I have a question. If we're interested in supplementing vitamins and minerals, how would you recommend we go about? Can we measure our like what we're getting from dietary intake and then decide based on that? How would we figure that out? Can we measure ourselves and see?
Well,
what
actually,
we need?
now that you mention it, I was once a part of the Kronos longevity study, and one of the things that they do all sorts of measurements. It was a study that was intended to you committed to being subjected to a whole bunch of tests for a certain period of time. Anyway, to make a long story short, part of that involved blood tests, and I used a lot of my blood test results to decide what to do. Now, actually, the Life Extension Foundation, if you look, if it's not in the issue of the magazine you got, they have blood tests that you can take, and they measure all kinds of things, and I used some blood tests. I found that I was low in potassium, and I'm not quite sure what the well, I mean, potassium is good for heart function and everything. So anyway, seeing that result, I increased I started taking potassium supplements, and also coenzyme Q10. I didn't think the levels of coenzyme Q10 that I saw in the tests were up to what I wanted them to be. So I've been taking more coenzyme Q10.
Okay, thank you.
Okay, any last question? Anybody? All right, so we'll take just a minute here, and we'll get set up for the next one. Thank you, Ben.